In my last class, we have seen the definition of the concept, function, domain, and range. Here, in this class, let us see some examples. The first example, let F be denoted by the set ordered by us 1, L, 2, M, and 3, M. See this rule or this relation by which the element 1 is associated to L, 2 is associated to M, and 3 is associated to M. That is, each element is associated to a unique element and hence it's a function. Definitely it's a function. What about the domain of this function? Domain means it is the set of elements having images. What are they? 1, 2, 3. Therefore, domain is the set 1, 2, 3. And what about the range? Range means set of images. Which are the images? L and M. Set L, M form the range. Second example. Let F be denoted like this. You consider two closed forms. Let the first one be capital X and second one be capital Y. These two are sets. Capital X contains the elements small a, small b, small c, small d. Capital Y contains 8, 9, 10, 11 and 12. Let F be a function from X to Y, by which A is associated to 8, B is associated to 12, C is associated to 8 again, and D is associated to 10. Here, this is also a function. What about its domain capital D? Capital D equal to set of elements having images. What are they? Elements A, B, C, D. Therefore, set A, B, C, D is the domain. And what about the range? Range, set of images. Which are the images? 8, 10 and 12. Therefore, set 8, 10 and 12. You see here, capital Y, set 8, 9, 10, 11, 12 is the codomain. And what about the range? Range is set 8, 10, 12. Definitely, range is a proper subset of the codomain capital. Now you see the third example, f of x equal to x plus 1. You see, this function is different from those two expressions. From the definition itself, you can understand this is a function which connects numbers. You know, x is associated to or x is mapped to the number 1 more than it. That is, the number 1 is associated to 1 plus 1, which is 2. The number root 2 is associated to 1 plus root 2. Minus half is associated to minus half plus 1, which is half, and so on. Therefore, by this function, which are the elements or which are the numbers for which we get answers or we get images? Any real number. Any real number can have the image that real number plus 1. Therefore, what about the domain? Domain is the set of real numbers itself. And what about the range? Range means it is the set of all images. What is the form of the image? Image takes the form x plus 1. The image of x is x plus 1. That means if x is a real number, x plus 1 is also a real number. That means an image is a real number. And can any real number be the image of an element? Definitely, because x plus 1 is the image of x, which is 1 less than it. That means 3 is the image of 2, half is the image, minus half, and so on. That means any real number can be the image of a real number which is 1 less than it. In short, we can say the image is a real number and any real number can be an image of this function. Therefore, range is the set of real numbers itself. As a fourth example, consider the function f of x equal to 1 by x minus 2. Here, when x changes its value, the value of 1 by x minus 2, that is f of x, also changes. In that sense, we can say x as the independent variable and f of x as the dependent variable. That means the value of f of x depends on the value of x. In that sense, we can write this function as y equal to f of x equal to 1 by x minus 2. Now let us think about the domain and range of this function. What about the domain? Domain means it is the set of elements for which we will get a valid answer. The answer is of the form 1 by x minus 2, and we get a valid answer only when x is not equal to 2, because when x equal to 2, this function, which is a rational function, 1 by x minus 2 becomes of the form 1 by 0, which is not possible. Therefore, we want to avoid the element x equal to 2 from the domain of this function. And you know, this answer 1 by x minus 2 can be obtained for any other real number for x. Therefore, what about the domain? Domain equal to set of real numbers minus singleton set 2. Now, let us think about the range of this function. What about the range? Range means it is a set of all images or set of all answers. The form of the answer is 1 by x minus 2, which is a rational function. What do we mean by rational function? Rational function means it is a function of the form p of x by q of x, where q of x not equal to 0. Yes, this is a rational function, 1 by x minus 2, and it can never be 0, because a rational function becomes 0 only when the numerator is 0. Here, the numerator is always 1 and it is non-zero. Therefore, this answer 1 by x minus 2 can never be 0, and any other real number can be in the form 1 by x minus 2. Therefore, what about the range? Range is equal to set of real numbers minus singleton set 0. As a fifth example, consider the function y equal to f of x equal to root of 1 minus x square. Let us think about the domain of this function. Domain means it is a set of all values of x for which you get answers. That means here the answers is of the form root of 1 minus x square. That means square root of a number. And you know, a square root of a number, that means in order to get the square root of a number, that number should be non-negative. If it is negative, you cannot find out the square root of that number as a real value. Therefore, what is the condition here? Or what is the validity, or what can you say about the validity of the answers here? The answers are valid only when the expression 1 minus x square under the radical sign, which is the radical sign, this means to take the square root, this simple. Radical sign should be greater than or equal to 0. That is, I repeat, we want to get the values of x for which we get a valid answer. Valid answer means, when will you get the valid answer? The valid answer is good only when the expression 1 minus x square is greater than or equal to 0. And you know, this 1 minus x square, I can factorize this as 1 minus x into 1 plus x. Therefore, I repeat, the domain of this function is the set of all values of x satisfying this inequality, 1 minus x square equal to 1 minus x into 1 plus x greater than or equal to 0. We can find out the values of x satisfying this inequality in the following way. First, you take the respective equation. What is that equation? 1 minus x square equal to 1 minus x into 1 plus x equal to 0. What about the roots of this equation? The roots are, what about the roots? Roots are 1 and minus 1. Now, you draw a real line with minus 1 and plus 1 on it. This is 0. Real line. Here, this real line is considered as, it is the join of three parts. First part is from minus infinity to minus 1. Second part is from minus 1 to plus 1. And the third part is from 1 to infinity. Yes. Here, let us find out the values of x satisfying this inequality in this way. You take first a value from the first part for x. Let that value, it is taken from which part? From minus infinity to minus 1. Let that value be minus 2. Substituting this minus 2 4x in the expression 1 minus x into 1 plus x, what will you get? Equal to 1 minus minus 2 into 1 plus minus 2 equal to, what is this? 1 minus minus 2 is 1 plus 2, 3. 3 into minus 1 equal to minus 3. What about this? This is negative. This means if you take a value from the first part from minus infinity to minus 1, this expression 1 minus x into 1 plus x becomes negative. That means if you take a value from the first part 4x, that x won't satisfy this inequality 1 minus x into 1 plus x greater than or equal to 0. Therefore, that part that is from minus infinity to minus 1 is to be avoided from the domain of this function. Now you take a value from the second part. Second part is from minus 1 to plus 1. You take a value 0 from it. Taking this value 0 for x, what will you get? 1 minus x into 1 plus x equal to, what is this? 1 minus 0. 1 minus 0 into 1 plus 0 equal to 1 into 1 equal to 1, which is positive. Which means definitely a value from the second part satisfies this inequality 1 minus x into 1 plus x greater than or equal to 0. Yes, this part satisfies this inequality, and so this will be a part of the domain. Now you consider the third part also. Third part is from 1 to infinity. You take a value from that part, let it be 3. Substituting 3 for x, what will you get? 1 minus 3 into 1 plus 3. What is this? 1 minus 3 is minus 2. Minus 2 into 4 equal to minus 8, which is negative. What does it mean? If you take a value, or if you give a value from the third part for x, that inequality 1 minus x into 1 plus x greater than or equal to 0 is not satisfied. Therefore, the only part of the real line is what? Which part? It is from minus 1 to plus 1. Satisfies this inequality. Therefore, what about the domain? Domain means it is the set of values of x satisfying this inequality, and hence it is the closed interval from minus 1 to plus 1. Now, let us think about the range. Range means it is the set of all images or set of all answers. Set of all images. You consider the function y equal to root of 1 minus x square. What is f of 0 here? F of 0 equal to root of 1 minus 0, that is root 1. It can be, you may think it as plus or minus 1. If you take plus or minus 1 as the answer or as the images, is it possible for the function? What happens here? For the value or for the element 0, we may get plus 1 and minus 1 as images if you take both roots for root of 1 minus x square. It is against the definition of function. Therefore, we have to restrict the function as y equal to plus root of 1 minus x square, or it can be 0 also. That is, we are taking only non-negative roots, or you can fix it as a negative root. Here let us take the positive or non-negative roots. Now you think, therefore y is either 0 or it can be 0 or it will be positive. That is fixed. Now if y equal to 1 minus x square, what happens to y square? Y square equal to 1 minus x square. Therefore, if you take all the terms to one side, what will you get? X square plus y square minus 1 equal to 0. You can consider this as a quadratic. Do you remember the usual expression of a quadratic equation? Ax square plus bx plus c equal to 0. And if x is to be real, do you remember the condition? For the real roots, what's the condition? B square minus 4ac. What is this? Discriminant of this expression. It should be greater than or equal to 0. Taking this in this equation, we want the values of y so that x square plus y square minus 1 equal to 0. And x has to be real there. Therefore, what can you write? The discriminant of this equation should be greater than or equal to 0. How can you find out the discriminant? What about b here? B means, what is b? B equal to coefficient of x, which is 0, because there is no term in x here. What about a? A equal to coefficient of x square, which is 1. What about c? C means y square minus 1. Therefore, what about the discriminant? B square minus 4ac. It is 0 minus 4 into a means 1 into y square minus 1 should be greater than or equal to 0. That is the product of these two factors, minus 4 and y square minus 1 should be greater than or equal to 0, in which one factor is negative. Therefore, what about the other factor? Y square minus 1 should also be less than or equal to 0. Only then this product of minus 4 and this will be greater than or equal to 0. Y square minus 1 less than or equal to 0 implies what? 1 minus y square is greater than or equal to 0, which is equivalent to the case of the domain. When 1 minus x square should be greater than or equal to 0, what about x? X should belongs to the closed interval minus 1 to plus 1. Similarly, here y should belongs to the closed interval minus 1 to plus 1. That means y can move from minus 1 to plus 1. But is it possible? Already we said y takes only the values from 0 and positive values. Therefore, what about y? Y belongs to the closed interval 0 to 1. This is the range. Next example, y equal to 1 by 2x minus 3 into x plus 1. Let us take the domain. Domain means it is the set of values of x for which we get a valid answer. Here, the function is a rational function. Rational function means, I already said, it is of the form p of x by q of x, where q of x not equal to 0. That means the validity of this rational function depends on the denominator. The denominator should not be 0. That is, we want to avoid the values of x for which 2x minus 3 into x plus 1 equal to 0. We want to avoid the values of x for which this 2x minus 3 into x plus 1 equal to 0. What are those values of x? X equal to 3 by 2 or minus 1. If x equal to 3 by 2, what happens? 2x minus 3 becomes 0. That means this product will become 0. That means denominator becomes 0. Therefore, we won't get a valid answer. This is the case when x equal to minus 1 also. That means we want to avoid these 2 points, these 2 values 3 by 2 and minus 1 from the domain of this function. For all other real numbers, we get a valid answer. Therefore, what about the domain? Domain means it is the set of real numbers minus the set containing the elements 3 by 2 and minus 1. Now, let us think about the range. Range means it is a set of all answers. You take the function here. It is a rational function 1 by 2x minus 3 into x plus 1. Can this function be 0 ever? Here, what about the numerator? Numerator is 1. And a rational function can become 0 only when the numerator is 0. Here the numerator is 1 and it is never 0. That means there is no possibility for the answer to be 0. That means 0 is not an image of any element of the domain. That means 0 is not included in the range of this function. Now, what are the other answers? What about y? Y equal to 1 by 2x minus 3 into x plus 1. Cross multiplying this, what will you get? Y into 2x minus 3 into x plus 1 equal to 1. That is y into 2x square plus 2x minus 3x minus 3 equal to 1. That is y into 2x square minus x. 2x minus 3x minus 6 minus 3 equal to 1. That is 2y x square minus yx minus 3y minus 1 equal to 0. As in the last case, this can be considered as a quadratic in x. And x is to be real. Therefore, what is the condition? Its discriminant b square minus 4ac should be greater than or equal to 0. b square minus 4ac should be greater than or equal to 0. What about b here? B means coefficient of x, which is minus y. A means coefficient of x square, which is 2y. And c, the last expression, minus 3y minus 1. Therefore, b square minus 4ac, what is it? Minus y square, that means y square, minus 4 into 2y into minus 3y minus 1. This should be greater than or equal to 0. That is y square minus 8y. If you take this minus sign outside, this becomes plus, into 3y plus 1 should be greater than or equal to 0. That is y square plus 24y square plus 8y greater than or equal to 0. That is 25y square plus 8y greater than or equal to 0. That is, we want the values of y satisfying this inequality, 25y square plus 8y greater than or equal to 0. As in the last case, we can find out the values of y satisfying this inequality by considering the roots of the respective equation 25y square plus 8y equal to 0. This is y into 25y plus 8 equal to 0. Which are the roots? Y equal to 0 or 25y plus 8 equal to 0 means what about y? Y equal to minus 8 by 25, which is equal to minus 0.32. Let us draw the real line with 0 and minus 8 by 25, which is equal to minus 0.32 on it. Similarly, this real line is divided into three parts. First one is from minus infinity to minus 8 by 25, then minus 8 by 25 to 0, then 0 to infinity. We need the values of y satisfying this inequality. Which inequality? 25y square plus 8y greater than or equal to 0, or y into 25y plus 8 greater than or equal to 0. Let us take a value from the first part. First part is from minus infinity to minus 8 by 25. You take a value minus 3. Let it be minus 3. Substituting this in this expression, y into 25y plus 8, what will you get? Minus 3 into 25y, that is 25 into minus 3. 25 into minus 3 is minus 75. Minus 75 plus 8. Minus 75 plus 8 is negative into negative. Anyway, it is positive. Negative into negative is positive. Therefore, a value of y taken from the first part definitely satisfies this inequality, 25y square plus 8y greater than or equal to 0. Therefore, this part, which is from minus infinity to minus 8 by 25, can be a part of the range. Now you take a value from the second part. Second part is from minus 8 by 25 to 0. That means minus 0.32 to 0. You take a value in between minus 0.32 and 0. Let it be minus 0.1. Minus 0.1. Giving this value for y in the expression y into 25y plus 8, what will you get? Minus 0.1 into 25 into minus 0.1 means minus 2.5. Minus 2.5 plus 8. 8 is greater than 2.5 and so minus 2.5 plus 8 is positive. Positive into negative, anyway it is negative. That means a value of y from the second part is not satisfying this inequality and so we want to avoid the second part from the range. Now what about the third part? Third part is from 0 to infinity. You take a value 2, 4y. Substituting in this expression, 2 into 25y means 50. 50 plus 8, 58. 58 into 2, anyway, it is positive. So, a value of y from the third part also satisfies this inequality. That means y takes the values either from the first part or from the third part. Therefore, what about the range? Range is the union of those two parts. What are they? Minus infinity to minus 8 by 25. Y can take the value minus 8 by 25. And union. Union of what? The third part. Third part is from 0 to infinity. You please remember, when I consider the range, I already said 0 has to be avoided from the range. Therefore, how will you write the third part? Third part is from 0 to infinity. That means 0 is excluded. Therefore, this is the range. Range is the union of these two intervals. Sorry, here we can't write this closed because minus infinity, it is not a particular value. It is not a particular value. Therefore, we have to take the open symbol. Therefore, range is the interval halfly open. Minus infinity to minus 8 by 25 union. Open interval 0 to infinity. Consider the function f of x equal to x if x greater than or equal to 0 and equal to minus x if x less than 0. This function is slightly different from the functions we discussed earlier. Here there are two steps. When x is greater than or equal to 0, the images are given by the part f of x equal to x. And if x less than 0, the images are given by the part f of x equal to minus x. From the definition of the function itself, you can understand x can be 0, it can be greater than 0 and it can be less than 0. Therefore, what about the domain? Domain means it is a set of all real numbers. Domain is the set of all real numbers. Now, let us take the range. For this range, you know, if what is f of 1? F of 1. F of 1, here the element 1 is taken for x and here x is greater than 0. When x is greater than 0, in order to get the image of the function, we want to take the part f of x equal to x. Therefore, what about f of 1? F of 1 equal to 1. Similarly, what is f of root 2? Equal to root 2 if you take the positive value. What is f of 0? It is equal to 0. What is f of minus 3? What about x here? X is minus 3, which is negative. When x is negative, the images are given by the part minus of that. That means f of minus 3 is minus of minus 3 equal to 3. That is, if x is positive or if x is 0, f of x equal to that itself. And if x is negative, f of x equal to negative of that negative, which is positive. That means in any case, that is when x is positive or negative, in any case, f of x is positive. Therefore, what about the range? Range means the set of, range is the set of non-negative real numbers. How can you write it? R plus union singleton set 0. That means it can be 0 or it can be positive. That means here you know, if you take the function once again, you know, if x is positive, f of x is equal to the same thing. If x is negative, f of x is negative of that negative. That means we are taking the numerical value of the element x as the image. And you know, this is the well-known function mod x, f of x equal to mod x. which is the absolute value function. X belongs to capital R. That is, if you see the function f of x equal to mod x, what is the meaning? The meaning is this: f of x equal to x itself if x is greater than or equal to 0, and it is equal to minus x if x less than 0. That means if the expression x between these two bars, if it is positive, f of x is the same thing. And if the expression between these two bars is negative, f of x equal to minus of that. In this sense, how will you define this function f of x equal to mod x minus 2? We can think like this. This function can be written like this: f of x equal to x minus 2 itself when x minus 2 greater than or equal to 0, or when x minus 2 greater than or equal to 0 means x greater than or equal to 2. It is equal to minus of x minus 2 when x minus 2 less than 0, or when x less than 2. As a last example in this class, you take the function f of x equal to modulus of x minus 2 divided by x minus 2. Let us think about the domain and range of this function. It is very clear that the domain is the set of real numbers minus singleton set 2. Because what? If x equal to 2, what happens to the denominator? Denominator becomes 0. Therefore, that value of x is to be avoided from the domain, because we won't get any image when x equal to 2. Therefore, what about the domain? Domain is the set of real numbers minus singleton set 2. What about the range? To find the range, we have to consider this part mod x minus 2 once again. Or how can you write this function in detail? F of x equal to modulus of x minus 2. Do you remember? Modulus of x minus 2 is x minus 2 itself when x greater than or equal to 2. Therefore, this function becomes x minus 2 by x minus 2. And equal to what? Minus of x minus 2 when x less than 2. Therefore, this function becomes by x minus 2. That is what? X minus 2 by x minus 2, what is it? It is equal to 1. What is this? This is equal to minus 1. Therefore, when x greater than or equal to, in all the cases where x greater than or equal to, what about the image? Image is always 1. When x less than 2, what about the image? F of x equal to minus 1. That is, f of 3, f of 2.1, f of 4 are all 1, and f of 1, f of 0, f of minus 3 are all minus 1. Therefore, what about the range? Range means we will get only two answers. What are they? Set minus 1 and plus 1. That's all. Let us discuss about the inverse of a function and algebra functions in my next class.